Welcome to this session on finite differences. In this session, we shall discuss the concept of finite differences and Newton's forward interpolation formula and Newton's backward interpolation formula. Assume that we have a set of values xi comma yi, ordered pair xi comma yi, where I varies from 0 on to 3 up to n of a function y is equal to f of x. Here x being equally spaced values. That is, xi is equal to x naught plus I into h, where I varies from 0, 1, 2, 3, etc. up to n. We have given this set of values. Now, suppose that we have to find some values of f of x. For some values of x in the interval x naught to xn. Which is not given in this set, or we want to find the derivative of f of x, for some x in this interval x naught to xn. In these cases, we have to define the differences. Okay. Now, if y0, y1, y2, etc., yn are the values of the function y equal to f of x, then we define the differences y1 minus y0, then y2 minus y1, y3 minus y2, etc., yn minus yn minus 1. These differences are called the first forward differences. This is denoted by delta y0. Delta y0 is equal to y1 minus y0. This is denoted by, that is the second difference is denoted by delta y1, third one is delta y3, and so on. This last one is denoted by delta yn. These are called the first forward differences. Here delta is the forward difference operator. Delta is known as the forward difference operator. Now, from these differences, we define the second forward differences, that is delta square y0, which is denoted by delta square y0 means difference of these two, that is delta y1 minus delta y0. That is equal to delta y1 is here y2 minus y1 minus delta y0 is y1 minus y0. This is equal to y2 delta y0 is y1 minus y0. y2 minus y1 minus y1 is minus 2y1. This is minus of minus will become plus, that is plus y0. Delta square y0 is equal to y2 minus 2y1 plus y0. This is the second order forward difference. Okay. And then delta square y1, which is equal to difference of these two, that is delta y3 minus delta y1. In similar manner, we can define any higher order differences, forward differences. Okay. If we denote this difference, that is y1 minus y0 by del y1, then we will call this difference as backward difference. Backward difference, first order backward differences. Okay, first order backward difference. This is the second one, that is del y2, y2 minus yn. If we denote this difference y2 minus yn by del y2, then we will call this difference as the backward differences. In this similar manner, we can define any order backward differences for a given data. Now, we will discuss the Newton's forward interpolation formula. Now, let x0, y0, x1, y1, etc. xn, yn be a set of n plus 1 values of x and y. Okay, here there are n plus 1 values because we start with x0, y0 and end with xn, yn. Therefore, these are n plus 1 values of x and y, and yn of x be an approximating polynomial. Satisfying y equal to f of x or the given data, and x being equally spaced values. Then the Newton's interpolation formula can be written as Newton's forward interpolation formula can be written as yn of x is equal to y0 plus p into delta y0 plus p into p minus 1 divided by 1 into 2 delta square y0 plus p into p minus 1 into p minus 2 divided by 1 into 2 into 3. That means 3 factorial. Here it is 2 factorial into delta cube y0 plus etc. In general, p into p minus 1 into p minus 2 etc. p minus n, n minus 1, that means p minus n plus 1 divided by n factorial, that is 1 into 2 into 3 into etc. up to n into delta n y0. Here p is equal to x minus x0 divided by h, x minus x0 divided by h. H is the interval length. Okay. Using this expression, we can interpolate certain values of y from the given data corresponding to x.